In the name of Allah, the most merciful and beneficent. I, Zubair Saeed, research assistant in a Swarm Robotics Lab, National Center of Robotic, NCRA, and also I am a General Secretary of the Community of Research and Development, CRD. I am here to present my paper presentation, that is classification of a pulmonary viruses X-ray and a detection of a COVID-19 based on invariant of inception version 3 deep learning model. Among other authors are Misharuj Khan, Ali Raza, Harim Khan, Javeria Javed, and Aksa Arshid. Contents. Throughout my presentation, I will be following introduction, objectives and motivations, proposed methodology, results and discussion, and in the last, I will be presenting conclusion and a future direction. Introduction. The coronavirus, pneumonia, and influenza disease have almost similar symptoms, where the COVID-19 has symptoms like fever or a chills, dry cough, sore throat, shortness of a breath, headache, loss of smell and a taste, muscle aches, whereas in pneumonia we may suffer in a trouble breathing, fever, pain in the chest, cough. We may have suffer these symptoms in influenza, and these symptoms are fever, itching muscles, sweat, dry persistent cough, and a breathing problem. Motivations. Coronavirus is a fatal disease that have already infected several million individuals and caused thousands of deaths globally. Any technical technique that enable quick testing of a COVID-19 with a high accuracy might be essential for the healthcare provider. X-ray images is an essential available technique that might be a great option for its quick detection. Proposed methodology. In our proposed methodology, we have a dataset acquisition, system requirement, pre-processing, dataset augmentation, and model compilation. Dataset acquisition. We have acquired the dataset from publicly available repository named Kaggle. The dataset was gathered by the researcher from a Qatar University, the University of Dhaka, Bangladesh, where the Pakistan and Malaysia collaboratively collected the dataset and published it online. This dataset has X-ray images from the patient infected with the coronavirus, pneumonia, and other healthy people. Here is a table showing the class type along with the total X-ray images against each class. We have total 21,165 X-ray images. There in a COVID, we have 3,660 images. For the normal, we have 10,192 images, while for the lung opacity, we have 6,012 images. However, for the viral pneumonia, we have 1,345 images. Pre-processing. We have resized the dataset in a fixed size of 299 cross 299 dimensions according to the required size of the inception v3 deep learning model. Dataset augmentation. We have increased the size of the original datasets into a 3 time by flipping, rotating and scaling respective images. We have total chest x-ray images of 27,165 belonging to the original datasets, whereas they become 81,495 after augmenting, which is 3 times the original datasets of x-ray images. Which shows the total number of the chest x-ray images with and without augmentation, a total of 27,165 images belonging to the original sets, whereas they become 81,495 after augmenting, which is the 3 times the original datasets. Here in the green there is original datasets, while in the blue there is augmented dataset against each class. Classification. Figure has been shown the classification results of a pneumonia class along with the achieved confidence during prediction using augmentation and without augmentation. Table has been shown the training and validation accuracy and a loss against each epoch. We have trained and validated the original and augmented dataset for a total 10 epoch and found these values during training process. Results. We have trained and then validated our Inception version 3 deep learning system using with and without augmentation approach. Here it has been shown that we have achieved the higher accuracy by keeping the learning rate of 0.0001 without augmented the dataset. Other learning rate of 0.01 and 0.001 using with augmentation, without augmentation, and the achieved accuracy can be shown from the respective table. Here we have the graph showing the training and validation accuracy and a loss of the system using with and without augmented dataset approach against total 10 epochs. Conclusion. It is concluded that the COVID-19 virus have dangerous effects on the health of the people. We choose Inception version 3 deep learning model and added 2 dense layer which ultimately increase the overall accuracy of our system. However, when a dataset is augmented, it achieved the better accuracy than the original datasets. The dataset with and without augmentation of a chest X-ray images is trained on a different learning rates, and the best accuracy is found by keeping the learning rate of 0.0001. However, as an extended version of this article, we can explore different other deep learning models that can be implemented with and without additions of the dense layer. These are These are the examples where our system has false prediction. The row 1 shows the false positives, however the row 2 shows the false negative examples of a COVID, lung opacity, normal viral pneumonia. These clinical characteristics of a coronavirus disease published in 2000s in China, whereas in the second we have performance of the radiologist in a differentiating COVID-19 from the non-COVID-19 viral pneumonia at chest x-ray images, while the third one is coronavirus disease, pneumonia relationship to the negative RT-PCR testing, while the fourth one is the COVID-19 ARC or not. Thank you very much.